Hello and welcome to my video. In this video I want to program burner. Actually it's a gas burner. So this is video only like for training or for understanding how it's working, because uh, this kind of equipment it's quite dangerous, and with this equipment you need to know exactly what are you doing, and with gas burners it's very high. uh, yeah, there should be definitely, uh, when you are doing this kind of project it's high risks, so you need, even with the selection of equipment, PLCs, different sensors and everything, you should be um, very accurate, and you should to know what are you doing. But okay, I did already some short documentation how it should work. uh, Let me check this. So here it is: technical specification, gas boiler burner control, purpose. I will put it bigger, I will make it bigger. The device is intended for automatic control of the gas boiler burn-on, uh, ensuring safe ignition, flame supervision, and correct shutdown of the burner in case of faults or by the operator commands. So the system is quite simple. System composition: air system, we have air blower fan, but sometimes it might be instrumental air if it's a small burner of or some kind of igniter of the bigger burner. Air supply, uh, to purge, yeah, combustion support. Okay, yeah, this is clear. Gas system, gas solenoid valve. So I have seen in the system sometimes the company is using at least two solenoid valves, or like different types of the valves, like solenoid valves, or like ball valve with return spring, something like that. Yeah, actually it's quite complicated. Gas pressure sensor on the line. Of course you need to monitor the line. You can use different sensor. It might be a pressostat, or some kind of uh, with analog output membrane. So there are quite many different pressure sensors. Ignition system: high voltage ignition system, spark igniter, standard thing. Flame monitor system, I selected two: infrared flame sensor and temperature sensor. So for example, if something will be wrong with one sensor, another definitely will detect that something is wrong. Start button, this one, I don't think so that we need this topic or this option here. Monitor parameters: gas pressure, variability, correct state of all sensor, uh, flame presence, ignition timings, start button status. Okay, yeah, this is clear. Operating logic. Standby mode, system in standby or in idle. Gas valve is closed, ignition disabled, air blower stopped. System start. When start button is pressed, or like signal, we get the signal. we are making the safety checks, gas pressure, and all sensor in the right states. If if there is some problem, we should to arrange some kind of flags or bits to trigger them. And these bits, they are very useful for alarm lists or fault lists or some kind of indication, and even for troubleshooting. It might be very useful because sometimes system without nice alarm list or signals, it's so complicated to operate, and no one knows what is happening inside of the PLC black box. So yeah. Okay. So yeah, to understand, you need to open the project, go inside, check where is the problem. Yeah, actually, it's a bit complicated and problematic. Startup. If any fault is detected, startup is blocked. System enters fault state. Yeah, system is going to fault state. Purge. Cycle if everything is okay. Air blower is on. Combustion chamber purge performed for predefined time. Yeah, we need to be sure that there is in the combustion chamber there is no some kind of flammable gas. So we want to, or something that can burn. We need to purge this out because like what is the problem with burners, boilers? So sometimes there might be some kind of leakage or gas inside. If there will be a special proportion of the mixture of the gas and air or oxygen, the spark will make the big boom, so explosion, and this is definitely not good, not safe. So with this, with like purge, we want to be sure that the volume not contains the gas. And of course we can check that air is working fine. Ignition sequence after purge, high voltage ignition is enabled, gas solenoid valve is open, ignition timer started. Yeah, I think it's good. Firstly, maybe we can start firstly ignition, wait a little bit, and after that start the gas. But yeah, I will check this later. Ignition timer starting. Ignition supervision. When if flame detected, both sensors with the ignition time. Yeah, if we see the fire, is fire detected, so we need to get information from the temperature sensor and from infrared sensor. If everything is fine, we can go to stabilization phase. If there is some problem, one sensor is not detecting the flame, so this is a problem. Maybe one sensor is broken, or like there is some kind of problem with burner, so we don't want to continue, and we're closing the solenoid valve. We're switching off the ignition and the system goes into the fault state. Okay, I think we can do everything in the fault state, so if the system will go to fail state, uh, this will be definitely off. Flame stabilization. Ignition system off. Flame continuously monitored by both sensor. This is good. If after stabilization timer everything is okay, we're going to normal operation. If something is wrong, fault. So also in this kind of systems, burners, it's very how to say, you need to make a very nice mixture. Mixture. You need to mix gas and the air with good proportion. So it should be there should be like optimal percentage of the gas and air. So if this will be wrong, the flame will be poor or there will be problem with the flame. I have seen this couple times. Actually, it's a very big pain to adjust the mixture, and if the uh, the burner is under, like, there is a pressure inside, it's more complicated. So yeah. So burner operates stable mode, continue monitoring of flame presence, gas pressure, sensor validated. Yeah, maybe this is also good. If there will be some problem, gas valve immediately close, system goes to the fail state. Shut down by the operator. When the start released, gas solenoid valve is closed. Ignition system, no, ignition system, it's already disabled. Okay. But still we want to, let's take this out. Air blower continues running for a definite post-purge time. After post-purge, system returned to standby mode. Okay, this is good. Fault conditions. Okay, so I already did project. So let's start. I definitely need a couple folders here. One is common. Uh, and I don't need quite many folders here. One will be burner. Structure text. And another I will make a simple digital in with a tone. So timer time, like, yeah, standard timer tone to like make a short delays between when the sensor, like, yeah, to reduce the contact bounce. So this is a good feature to make a very short delay. So I already prepared the types for this project, so to save some time. Okay, here they are. Yeah, let's start with simple digital input. Boolean. So this is for the input. Uh, okay, this is fine. Okay, this is also good. Input. Boolean C. Input and output U. Will be yeah. Oh, okay, we can start from also to make a burner. I also already prepared all variables for this work to save time. So just copy those here and that's it. To be honest, I already have a project of this burner. Mm, I did. I finished this couple of days ago. I'm just looking sometimes there to see, like, plan what I need to do and how I need to program. But yeah, with this, without this kind of information, it's a little bit complicated to program. Yeah. Hmm. Also, I need this one. So let's start. Keys. Couldn't step off. Yeah. Also, let's okay. So yeah, this is my inputs, outputs, additional variables. this is my steps. Here I will keep error, test mode, step timer, uh, error bit, error number. Yeah, I don't think I will use this one here. Flame possible. Okay. Okay. So we are starting from idle. I will put here everything. So idle. After that, preparation step 1, preparation step 2, ignition, stabilization. Yeah, okay, let's continue. So stabilization. Stable. Stopping. And error. Okay. One thing that I don't like in the TwinCat 3 that inside of this I don't know where I can uh, align my text. So you need I read that you need to download and that here some kind of additional software. So yeah, not very useful. But okay, let's start from idle. So we don't want to keep error the step in the memory. So this is the double word, I think. Yeah. So this is in the hex. What else? Oops. Outputs. False. Oh, I did couple changes on fly with the camera. So yeah, this will be a little bit better now. Okay, let's continue. So here now false. Solenoid valve and igniter also false. We need to move somehow here. So let's use this one. If after that we are checking the sensors. If there is gas pressure, and there is no flame, no temperature, no temperature inside of the burner. There is no airflow. Then next step, be this one. So to use the steps, mostly I'm using this kind of structure. So yeah, this is very useful structure. So what else? We need to check if something is wrong, like something from here is wrong. So let's use else. Uh, if there is no gas pressure, This is good. So, if there is no gas, we are setting bit 0 uh, in this variable. So if there is a flame, bit number 1. So number 2, last one, number 3. Yeah, really, this is looking good. So 32 minutes. I hope I can fit in 1 hour, because if it will be more, it will be complicated for me. Firstly for me. Okay, so here I will use one structure that I'm using quite often. So if a step not equal cooling step, so on the preparation I want to activate air. Burner output air. True. What else? Here I have a step timer somewhere. I want to raise it or keep on the switch off mode. So step timer post Q. Oops, sorry. I need 0 sharp. Okay, this is good. Want to keep the test mode always true, but yeah, here I will not use the step mode. Oh, sorry, test mode. Maybe I will add later. Let's activate the step timer. Wait, 5 seconds. So air is on for 5 seconds. Uh, if the timer is activated and we have air here, that will be, but if there is no air, this is definitely a fault. So yeah, let's use the same structure. So in this step, I want to activate the burner igniter. Output. Oh, so yeah, now let's activate the igniter. Let's use again the timer. I think 5 seconds. It will be like 100 milliseconds. If there will be some flame, even flame. Actually, I want to use from optical sensor because for temperature I always need some time. And then I don't remember for stiff. The timer Q. there is no flame and there is no temperature. There is no temperature. Then next step. Okay. So I want to add one variable here. Of this variable. If so if there is air and the solenoid valve is open, so flame is possible. I don't know. Let's hold. I think it should help me in the next steps. So what else? Okay, standard instruction. Okay, let's open the solenoid valve. Okay, solenoid valve now is open. So we should already start detect the wire. So let's activate the timer for 10 seconds. So we have like only 10 seconds to uh, detect the flame. So the idea to detect the flame before these 10 seconds uh, will be triggered. So if So next step, stabilization. So if the stop timer is triggered, okay, this is good. Stabilization. Standard construction. Okay, I want to deactivate the igniter. Let's activate here the timer. 5 seconds will be enough. So now I want to see both sensors and the timer. Here something is wrong. Hmm. Hmm? Mm, yeah, I think we are quite good. 50 minutes. Hmm. So stable. Again, say everything is same. Same construction. So in this step we will just monitor the both sensors and that's it, I think. Ah, and the button. So if there is no flame and no temperature, I mean the temperature sensor for flame detection. Timer true. 3 seconds, I think, will be enough. So the both should be on. Okay. Leave the timer. There will be another error. I think I forget to do something here. Ooh, oh yeah, I need to add another error here. Hmm, looking fine. This is looking good. Yeah, I'm a little bit tired already. So yeah, if the button is released, then boom, save is stopping. Okay, let's use standard construction. So I want to close the gas valve. Activate the timer for 10 seconds. Um, the timer is activated. Uh, the be idle. Okay, so error. We need to go out from this state somehow. It will be fine. I think this one also will be fine. One signal. This one. Yeah, I have one signal input. It's external error. We will use definitely the signal in the program. So this might be some kind of emergency stop or something like that, or additional sensor, or like sensor additional safety PLC something. I don't know. So one more thing I want to add here. We are going here somewhere in the program. So the program is doing some kind of activities, and we will switch off the operator switch on button. It will not switch off the system. That's why I want to uh, make a small logic. So if we are not idle or error, error stop. It is. So, uh, stop, stopping, turn. If human puts, there is no command. That would be this one. And if oh, many. Okay. So yeah, the program is finished. So let's try to build. Wow. Mm. Yeah. Uh, yeah, I know why there is no error. So like, it is looking a little bit weird. Hmm. Yeah, definitely, it's looking strange. Oh yeah. Here, let's try to compile. Hmm. Yeah, now it's wow because there is no problem with no errors, no some kind of faults, no nothing. So yeah, this is looking nice. The structure is looking fine. So next video I will make some tests, maybe some faults. Maybe I will do two videos. One with a test of this logic, another will be with to test faults. Uh, yeah, so this program is looking quite nice. What else? Yeah, you can use this draft code wherever you want, but please be very careful with that. Please test everything, check everything. This is not tested on real equipment, and the code and this kind of tests in virtual, this is like nothing in real life. Everything is different, so please take this code and use carefully, or change wherever you want, and do with this code wherever you want. So yeah, as I told you, the code is not tested. It's not for some kind of tested on some kind of equipment. It's like for education, or like for my training purposes. But yeah, 1 hour 7 minutes. Thank you for watching. I hope this video will help someone with coding. Thank you, and bye bye.